So this machine looks a little bit complicated, but we're going to brainstorm and break these steps down into their individual components. So as we watch this process, we'll see that the first thing it does is run the box up until the item at entry photo eye is made. We can modify these views right here, by the way, if you go to options, view, and you can click on sensor and actuator tags, and that will display everything. So we're going to look at this first step, and we're going to go through our entire process and brainstorm in groups and come up with a list of steps. Those steps in turn will become our step logic, and we will program to those steps. So this is kind of a linear process, and what I want you to do is first brainstorm and get your steps, and then we're going to translate those into ladder logic. So at this point here, we'll pause and get in groups and brainstorm the steps of this process. Use your factory IO to look at the different things. You don't actually have to run the program, but you have this to look at, and I'll let this run for a few minutes while you decide what steps to put in the program. So at this time, if you haven't done so, you need to pause and finish your group work. But now we're going to go through some of the steps. And so I came up with some steps, and they're in your lab manual to get you started. So let's look at what I came up with, just the first few. I'm not going to do them all. We have a solution at the end. You want to look ahead if you're an instructor. So we look here and we see that I started in a linear process, and I said run the widget on the entry conveyor until item at entry photo eye is made. Notice that I'm always adding feedback into these. You always have to add feedback. So when we get through with this, make sure you add the feedback to your steps. So if item at entry photo eye is made, extend z-axis down. And then if item at entry photo eye is detected or is made, engage the grab solenoid. So those are, you kind of get what we're going with this. Let's look at your sample program, and I've filled in quite a bit for you. So it's a blank program. You're going to fill in the steps. You may have more steps than I do in my example. That's okay. So here we have our steps. And if we look here, looks like we'll have to add some of the descriptions here. But basically, we have an auto if active button. So we just have our start stop button. We press that, and then it becomes active. And then we start the process. Notice that each step is a DINT word, and that I'm using each bit. So step 0, step 1. A lot of times when people program this, we would leave this blank and we would just skip a step. And if we come back later, we have a nice logical place to insert a step. So we would just go to step 0. If I delete this add feedback bit here, because that's just a placeholder, if I delete that out of the program, then it will simply just go through there. You might turn your timer down to 0. And then once you get it running, you can come back and delete the unused steps. Notice that step 0 goes here, it makes step one goes here, etc., etc. So we're going to go through there. Now, what I'm going to do is I'm going to add my descriptions. And so I'll go back to my little diagram and I will take the whole description that I come, the whole step, and I will make that my description. So, and if we go back over here to the next one, so we'll come over here, and so we'll simply come over here, and if there's anything to be done, we can add a delay or we can turn it off. If you don't need the timers, you can simply just put a 0. So we're going to have this first command. Since it is our first command, there really is no feedback. So we'll just say when it's an auto active, our command is to run the widget on the entry conveyor. Well, I take that back. I guess we don't want to run it unless if the photo eye is not made. So what I would do here is I would come over to my program and this would be our item at entry. And that would be our first step. The next step, we've made this part here, we would add feedback here, and we are going to do a item at entry is made. And here we have our next step. Now, what happens here is people will start trying to put their outputs down they've got it in their mind that they've got to be programming their outputs. And I'm going to tell you right now that this will work. The outputs will program themselves if you add the feedback in each step. And I'm going to show you how in the rest of the program. So what we're doing here is we run through each step with confirmation. Don't worry about the outputs yet. So once we've programmed all of our steps, if we look through here and we get all of our steps programmed in and we've gone all the way and we've completed moving a widget to the exit, then I have to reset this process. And so the last step, of course, needs to reset the process. You also probably need to add a reset button. This is your reset button. Because you have to give the way that for the operator to manually clear, because it's an eventually something will happen. It won't hit right, or you have a bad widget and it won't pick it up, and they'll have to have a way to clear the jam and reset. And here we'll just say another way is to do the emergency stop. This machine has a machine stop, so we're just going to put the emergency stop. If they slam it, then we clear the logic out and they have to restart the process. And so this is our reset. Notice that it is moving a word 0 or 0 into the entire word. So here we have latches. We don't need to unlatch it because here we are basically wiping everything out. And so this serves as a global unlatch for the entire word, this little bit of logic right here. Now, we talked about the outputs. Let's look at our outputs here. And I told you they would take care of themselves. So, for example, here we have run, this should be entry conveyor motor. And what we want to do is we want to run it if we are in step 0. Get rid of these, don't leave those in there. And except if It is in step 1. So how we're going to program this is if we're in this step, but not the next step, turn on the output. Are you with me so far? Let's go down and do one more here. Let's go the Z command. Now, how many times does the Z command solenoid have to go down? Well, it's got to go down once to pick up the product, and then it's got to go down one more time to place it on the exit conveyor. So it has 2 conditions within the steps that make it come active. So let's go with, we'll go, try to export our data really quick. Now I've exported it from the working program, and what I'm going to do is we will import it back in. And so here we have our move Z command. And so if the emergency stop is pulled out and we're in auto active, and we decide that we're in step 2, which is the command to move the Z axis down, but we're not in the step that retracts it, then we're going to fire the Z command solenoid and it will move down. Now this has to happen twice. In the next step, I add a parallel branch for the second time. And in my brainstorming, I came up with that when I want to, it says extend Z arm onto the exit conveyor, but I'm not into the retract arm step. So there are 2 commands, or there are 2 times when I want to extend the Z axis down. And that's when I pick it up, and that's when I place it. And so if you have to add a third or fourth, you simply add a parallel branch. A little trick here is right click, add branch level. Now you've got, if there was a third time in your step, you would just keep putting it in there. So what I'm telling you now is don't get hung up. Program your brainstorming steps into all of these, into the step logic. The last step is adding the output. So make sure you get all of this working and then add your outputs in this step, but not the next step. And, you know, of course, sometimes you might have a big gap of step 2 to step 4, et cetera, however it works out. So make sure you do that and continue on with the exercise.